Okay, class. So the next thing we want to do is add in our locations for where the birds collided with buildings. So we will add in our lights out locations, that CSV file. Then we will assign it the coordinate system. So we'll right click on that CSV in the table of contents, go to display XY data, tell it which is latitude, which is longitude. And we will double check the coordinate system. ArcGIS will guess at what it thinks the coordinate system is. In this case, this is incorrect, so we need to edit. Our lights out data is not projected, it's unprojected, so we open up geographic coordinate system, and the datum is based on WGS 1984, so we open up world, and we scroll to WGS 1984. And hit OK, and OK, and OK. That's our warning that the locations do not have a federal ID number, so they don't have a unique ID number associated with each row. So we will need to export this shapefile. So we will right-click on it and go to Data and Export. And we will save it to our thumb drive in our ENST 456 folder. Let's call it LOUMDEXP, or we can spell out export and hit save and OK. And yes, we want to add it as another layer to our map. Now remember, this exported data is based on an unprojected coordinate system, and every layer we use has to match. So we need to project this layer. So we go to our toolbox, and we will open up our data management toolbox. And from there, we'll go to projections and transformations. And in your version of ArcGIS, you may see feature or you may see project. And we know this is a feature rather than a raster. So we're going to, in our case, we're going to open up feature and then project. And the input is our exported LO lights out UMD exported shapefile. So we select that as our input data set. And for the output, so where do we want it to be saved? We make sure we're still in our ENST 456 folder. Now let's call it something like LOUMD UTM. So that'll tell us that we are projecting it to UTMs. Now we have to tell it that system. The output coordinate system, we're going from WGS 1984 to projected in UTMs. So we open up projected coordinate system. We want to go into UTMs based on a datum of WGS 1984. Open up Northern Hemisphere. And now we find our WGS 1984 UTM zone 18N, since Maryland is in the 18th zone. We hit OK and OK, and this will come up as a new layer in ArcGIS. And it just takes a little while. And once that comes up, then we can start simplifying our table of contents by removing those features that we no longer need. So we don't need our original events. So those original locations, we can remove those. We want to keep in our roads layer. Now that we have projected our locations into UTMs, we don't need the exported layer. So let's keep our boundary, our roads, and our UTM. So let's say we're interested in seeing the distance between all of our locations and the closest road. So for that, we're going to use the analysis toolbox. So open up analysis, and we will open up proximity and click on near. So we are going to ask ArcGIS to calculate the distance between what we input. So we're going to input our UTM locations. And what is it near? So near our roads layer. And remember, we have to be in the same projection system, which they are. Then we hit OK. So now when we open up our UTM, our lights out UMD UTM, we're going to open up properties. Make sure everything's set correctly, which it is. Great. So, okay. So now let's open up the attribute table and see that it did add in the distance. So first we see our federal ID number, the shape, the date, latitude, longitude, location, species. So that was the data from our original CSV data set. Now we've added in this distance between each location and the closest road. So is we could save this attribute table as a CSV file and then run some analysis in program R. So to save this as a CSV, we go to this down arrow at the table of contents. Once we've opened up our attribute table, of course, we can export, change the name to lights out UMD, let's call it D for distance. We're going to change this to a text file. Now we're going to override .txt. We're going to override that and save it as a .csv. Make sure you're saving it to your ENST 456 folder. And then save. So now you're saving, and yes, you can add it as another layer. Now you're saving that CSV of all of this data. You're saving that you can work with separately in R. But let's keep going for now. Let me zoom back to our layer. Okay. Now let's say you want to see the hotspots. What areas on our campus seem to have a lot of density of collisions, of birds colliding into buildings? To do this, we're going to go to the Spatial Analyst toolbox. So let me shrink down these others. So Spatial Analyst toolbox, and then density, and these are all points, so we'll go to point density. So the input, we want to input our UTM locations. Output raster, so where do we want to save it? We want to save it to our thumb drive. Let's call this lights out UMD density. And we're going to let ArcGIS, we're going to use all their default settings except for unit area units. We're going to change that to square meters because we're using everything else in meters. Then we'll hit OK. It's going to go across all of our locations and determine where the areas of hotspots are, so the greatest location. So let's turn off all of our other layers so we can just focus on this one layer. So darker colors in this scenario, the darker blue indicates a greater density of points, whereas a lighter blue indicates very few locations. So here are our dark spots. Now we can classify or reclassify this layer to really make this stand apart. Like if these colors aren't very significant, we don't care about these 0.0006, 0.007. If that isn't very intuitive to us, if we just want zeros and ones, either you're very densely packed or you're not, we can reclassify our raster. To do that, we'll go to in our Spatial Analyst toolbar. Now we're going to go to reclassify and reclassify. Now we're going to enter in our raster, that lights out density raster. Now we're going to change it so that all of these other layers that we don't, or all of these other values we don't care about, we're going to make those zeros. So we only want our most dense locations to have a 1, to have a value. So we want these first rows to be zeros. And then we want only the highest value to be given a 1. So just 1s and 0s. We'll check the box, change missing values to no data. We're going to save this to our ENST 456 folder, and we're going to call this lights out UMD den for density, rec for reclass, and hit save. Now it's going to go through and convert everything to 0s and 1s. So now we have a much more simplified raster. So now 1 is represented by green, 0 is represented by pink. You can always click on your eye tool, your information tool. So this is much more obvious to someone looking at your map to see what's important or not. And you can reclassify any kind of raster with whatever values you want. And remember, you can change the color of these as well. So you're going to keep this open. You're going to keep these layers open as you take your quiz and as you answer this week's discussion section. So I hope you enjoyed this week, and I will see you all at Open Office Hours.